Okay, so this is the recording for 11/21. A couple of things. First of all, this is not my first time start trying to record this. I made a couple errors like opening my email, all sorts of things. Um, so I apologize. I'm not going to skip anything. I'm going to make sure I go over everything, but it's very, very important that if something feels skipped, to let me know as soon as possible. I'm going to record this one, then I'm going to record the other one as soon as possible, possibly over Thanksgiving break, and make it available the second I can. So up to this point, Spring Boot and web server, all the work we've been doing is stateless. Session work involves connecting those stateless requests and responses with each other, right? So how do we identify that one request belongs to the same person? Um, we need session management. Session management is generally a web container framework tool. For Spring, it's just simply the web container that we're going to be using. It's a tool that allows us to store session data. Now, the good news is Spring's going to do most of this work for us, which is pretty awesome. But we're going to talk a little bit about what we can do to mimic this session-like behavior. We could use cookies. Cookies is data sent from a website and saved by the user's web browser on the user's computer as the user browses. We don't typically do this. If someone turns it off, as an example, then no session stuff will work. So nobody will be able to log in, nobody will be able to do this, nobody will be able to do that. So it's a very, very bad idea. You could use a hidden form field and just pass form fields along with the request. But in order to do that, the data would be very much hidden, especially login information, username and passwords would just be visible everywhere, not secure. You could use URL rewriting. It's another tool that you can manage requests and responses with, you have your hidden form field, but you're going to go ahead and rewrite it so it never shows up in the browser window. Unfortunately, it still shows up in the web pages. It still shows up in quite a few places. And so it's not any secure than using the hidden form fields. URL rewriting is actually for different purposes. It's not built to handle this type of work. The final way we can do it is use HTTP sessions. So HTTP session has a container framework. So the Spring Boot system has something called an HTTP session that actually manages the sessions. Typically, it manages sessions. Most containers do something like this. It puts a header in the new request, and then it continues to ask for that header. And the browser knows to keep sending the header in future requests. By doing so, that token, it's not like a web token. We'll talk about that later. But that token gets passed to the web server, and then the web server uses that as an index into its own system to go and then find information that it's stored about the particular user. That session object, it is an object, is very, very important in most web applications. Now, we have a problem, Houston. Up to now, because our HTTP protocol has been very stateless, you could match any web server with any request and simply put, I'm checking the microphone, and simply put, any server can handle any request. However, the second we start storing information about users, we now need to deal with what we call production problems. So typically we had to have a load balancer in front of our servers that would actually, pass out information to different servers. Session sort of destroy that ability to distribute that work in a production environment. So that's a huge issue. We could use a sticky session. By using a sticky session, that means that the load balancer is aware of sessions and routes all the requests back to the origin server and so forth. So same requests, same clients go to the same nodes. That works pretty well, but if one node goes down, the session is gone. That's not that big a deal, but it also sort of destroys load balancing in a way. All right, imagine you get 100 requests. every third request, and you have 3 servers, every third request is a very short request. But the first request, everybody's on there for like 10 minutes. You can tell that the first server would be worn out, right? If simple round robin strategy, the first server would be worn out while the third one's handling most of the request. That's not what load balancing is for. Load balancing is designed to distribute the work, not distribute clients. It's not really what it's meant to do. We could do session replication. So in that sense, the load balancer just sends it to all the servers, just like before, but the servers are actually passing off that session information to each other. We do this with distributed databases all the time. So this is just another tool in the shed, so to speak. However, if a node goes down, the session data would not be lost, but the workload on the servers goes up dramatically, unfortunately. Oddly enough, right, databases have optimization things that allow them to do things very, very rapidly, whereas web servers generally do not as it relates to session data. There's no easy way to do it, and therefore it's no efficient way to do it. So what we typically do is use session data in a persistent source. So rather than having each server hold on to the session data itself, we're going to actually store them in a database. Remember, I just said 2 seconds ago that the database can store these things very, very, very efficiently. And so that's no different. That's exactly what we're going to do. In this case, the session is not stored in server memory, it's stored in a database. And that's what we already have a database, so we're just going to connect it back to that. And that's all we're going to do, right? It's not even fancy. So we'll talk about that, and we'll talk about how boot manages that. Now we have one more thing we have to discuss before we can actually even get to code. But before we do that, I'm going to go ahead and talk about the Spring start.spring.io. We have one more dependency we have to pull in, Spring Session. So you can see I go ahead and create a Maven project. I use the most recent Spring Boot version, put in my group, I put in my artifact. I want jar, I want 17. I want the web, JPA, validation, MySQL driver, and session. What we're going to do is we're going to load that October 14th, and I'm going to actually copy the stuff in there. So in order to do that effectively, I actually need to have all the things from that other web server. Now, I've actually already done it, so I'm not actually going to generate it. I don't need to. But we actually do need this dependency. It's very, very important. Whenever you need dependencies, it's always easier to add them via the Spring Initializer and then copy the code in as necessary, then try to create it and then fix it later. Unfortunately, because we want to do the session in the persistent data store, we still have to manage, we still have to fix a dependency, but we have to do that one manually, unfortunately. So let's get in there and see. But before we do, I want to talk about cross-origin requests. So we're going to go ahead and open. The other one was October 12th, was our old system. And I'm going to go ahead and close all of them. I don't need any of these open. And so this was our old system. But we have a student controller, right? I already have it in here, unfortunately, because like I said, I didn't do it, but we have our cross-origin controller. Now, what is that for? Cross-origin resource sharing is cores. We'll actually throw a couple wrenches. So what do we mean? Well, when we make a request to our node server, our Node.js server at port 4200, it handles the request and sends the request as necessary to 8080, which is the Spring Boot server. In other words, there are more than one request going on. If we don't manage sessions properly, what ends up happening is we connect session-wise to the Node.js server, and great, but the Node.js doesn't translate those credentials and then creates their own credentials. So in other words, we break the credential chain, which is terrible. So all we need to do is specify that we want to allow credentials across the organ. And that's all you have to do is set allow credentials to equally true. The second you do that, those Node.js stuff works very, very well. All right, so one other thing we have to do, I already put it in here. I told you I have a lot of work already done, but we're going to set the Spring Session date store type, and we're going to set that to JDBC. Now, we have a huge problem, and it's very important that you understand why this problem exists. You need this next line. Why? Because by default, Spring JPA Hibernate DDL Auto is off. We actually assume that the database was created via a populate and setup process, and as a result, we want that off. And we do want it off, because otherwise it'll actually recreate the database every time, which is absolutely bad, terrible thing to happen to your actual server. Very, very, very bad thing to happen. So we want that to be off. But when that's off, the session store can actually create its schema. So you have to actually set Spring Session JDBC initialize schema always. And that way it will actually initialize the schema for the JDBC stuff. Yay! And you go, wait a second, really? Yes, but wait, there's more. There's one other thing we need to do, and I saved it in a text file, so I'm going to go ahead and oh no, let me make sure I didn't already do it. I might have already done it. So remember I told you we had to modify the yep, already done. We had to add one dependency. We had to add one dependency. What I did was I copied the Spring Framework session, the Spring Session core, and I copied it and pasted it right afterwards. And I just changed the artifact ID for the second one to Spring-Session-JDBC. And now it'll have everything it needs. So I'm going to go up to the package, and then I'm going to go clean and build. And then it'll go ahead and download the dependencies that we need that'll actually make it work, which is huge, right? It's huge. It's a very important deal, which gets us to the point. Now, let's talk about our application. We're going to talk a lot about logging in, and that means using usernames and passwords. Now, before we get too far, we'll need some notion of users. For our application, we're going to keep it very simple. We're going to have a username with a password, and we're going to have an admin Boolean, a field which indicates whether or not you're a Boolean or you're not a Boolean or whatever. Or excuse me, you're a Boolean or not. You're an administrator or not, essentially, which is what we want, right? Okay. So I already created the user, as you can see. ID, username, password. Admin is true. It should be set to false. We want admin to be false by default. And then you need getters and setters, including the admin. So make sure you do that. Otherwise, it won't translate the object when you pull it out of the database. You need those getters and setters. But before we do that, now that you know what a user looks like, you can see I already set it up. I set up the database. Okay. I drop the table student, I drop the table user, and then I create table user. Username, password, username varchar primary key. We're going to just use the username as the primary key, which makes sense because the username has to be unique. And then the password be varchar 20. We should probably make that 30 and like 30 because that way we can have a longer password if we wanted. And then admin's just a Boolean field. And then the user is created. Pretty simple. But because we're going to have the users manage the students, what am I going to actually do with that? Well, what I did was I just created an advisor field, and I need to make that 30. I created an advisor field. You see I have the regular fields. I just added an advisor field. But this advisor field is not just any field. This is what ties, this next line is what ties the advisor field to the user username. All it says is foreign key, and then it indicates which foreign key in the table, in our case it's advisor, references which table, the user table, and which field in the user table, its username. Okay? And that's how it ties it. Now, if I go to, I'm sorry, hold on. If I go to insert a user, if I go to insert a student, that student better have it needs to have an advisor, although it's not, I mean, there's no null and blah, 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 but it has to have an advisor, and that advisor has to be in the user table, has to be there. You cannot add a user, you cannot add a student that does not have a advisor that's not in the user table. So pretty simple. And then I created two advisors. I used my first name and my last name, since they're both short 4-letter words. I know you probably use them as 4-letter words. Ha, 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 right? Insert into user values, and I insert, Mike's going to be an admin and Ruth is not. Okay. If you have a Notion of admin, I highly encourage you to create an admin and a user, and simply put, just make sure that you check, user passwords, all those things. Excuse me, nothing worse than getting it wrong, right? And then down here, I just added an extra field for advisor, and bang, I ran it. So I just changed the setup field. So let's run it again. Yay. And then I populate. And I think I only put 10 people in. I don't remember. I know I just copied this from the most recent thing. So it doesn't have 5,000 records, but yeah, it has like 10 things. But you can see Mike, Ruth, Mike, and there's no errors. If I tried to insert one that did not have Ruth or Mike, because those are both in the user table, it would fail. Okay. All right. So now that we have our data and we have a generation code, the next thing we're going to do is create our object. Now, this is the part where you might get a little annoyed. Instead of calling it student, I just called it web app because I'm going to put everything in here. But I created a user. Very simple, username, password, admin. It matches exactly, but there's nothing fancy about it. And then I created a user repository. Right. The only thing I'm going to add, and I haven't yet, I don't know why it's not here yet, user find by username. Right. And of course, that is the primary key, right? So great, right? That is by default the primary key. So we can use the exist by and that. Pretty simple. You note we actually, although we have lots of fields in the student repository, we have a find by SID. And the main reason for that is just so that we don't have to use the optional bit. Okay. Now, student controller already has the code, unfortunately. Okay. I already put it in here because I've done this like 5 times now. So I'm going to comment it out and add it back in. Okay. I know, right? Actually, you know what? I can simply do this and save it in there and save it to the desktop. Oh, okay. All right. So now I just wanted to talk a little bit about what I did. I added the auto-wired user repository. But what I also did was I removed all the BS. We had 3 get mappings for student. Actually, here we have 2. I'm going to get rid of the second one, right? We don't need 1. We don't need 2. We have a get major. Get rid of you 2. Wait, hold on. Yeah, and we have another get mapping because we were showing you how to do get mappings. I'm just going to keep the CRUD stuff and keep it simple. We are going to do a couple more. We have a post mapping, and then we have a put mapping, and then we have a delete mapping, and then we have a get by SID, which we have here, and then we have a get all students. Okay, what we're going to do, and we're going to do it one at a time, very quickly, unfortunately, but yeah, we're going to get rid of you too, buddy. We don't need to know how many students there are. So great, right? What we're going to do essentially is we're going to work on, now that we have a user, now that we have all the things we want, we're going to work on a login, obviously, but we're also going to work on authentication authorization. So authentication is the process by which we prove to the server that we are who we say we are. So typically it's a username password, right? Cybersecurity kids would think, oh, you're providing knowledge, right? You're using knowledge by indicating that you're so we're going to do a login test. This will be our first get mapping. And I'm going to return a string, and we're going to call it login test. Excuse me. And I want everything to work, so I'm going to just return an empty string for now. Okay. So what we want to do essentially is we don't trust client client code to do anything because it can be easily manipulated. So the server should always handle this process, right? This should not be handled by a client. But the job is to determine whether or not the user is they say they are. Typically, if they provide a username, they should provide a password or something to indicate that. And that knowledge of the password is the way in which we indicate that we know who we are. So we're going to provide authentication, but we're also going to work a lot today on authorization. Authorization is what the server allows us to do based on who we are. Again, server should handle this. We only allows them to see what the user should see. We can't trust the client to do this. We'll use fields from authentication such as admin to show things if we want to, but they won't work without authorization from the server. So essentially we'll work on all these mappings down below, get mapping, get an individual student, get all the students, add a student, change a student, delete a student. We'll be doing quite a bit of that, but we'll be only doing it in the sense that you have to be logged in to add a student, look at students and those things, but sure. But you have to have an account to be able to do these things. But additionally, we're going to have some notion of the admin being able to look at all the students while the advisors are only able to look at their students, if that makes sense, right? That's our overall goal. So first we're going to do a login test. This depends heavily on what we call dependency injection. So the login test, I'm going to use the request. Sorry, this piece of paper on the side of me. I'm going to use the request. I'm going to use the HTTP servlet request. With the servlet request, I now have access to the session. Right? You need a servlet request, not simply an HTTP request. The request, by the way, you can also look at the headers if you chose to. I usually don't do anything with this, but I was going to point out that the servlet request actually, since it's a server, actually has attributes and storage associated with it as well. We don't want to do this. We want to store session data that connects the user to each other. If we wanted to store it globally, that's why we might put it in a different type of object, but that's not what we're trying to do here. Session is where we need to actually store that information. So we can get the session here. 90% of the time, we're going to do something that looks like this. No. Else. I'm just going to return different strings based on what's happening. So we're going to return null if it's not null. And then we know it's not null. So we're going to go ahead and get the session. And then we're going to get an attribute on the session. In our case, it's going to be user. If that's not set, excuse me, if that is, sorry, I know you might be able to hear my dog barking. I apologize. If that's not set, then the user is not logged in. Right? I mean, that's essentially, because once we actually log in, we're going to be actually set an attribute. Else it is, we're going to go ahead and get it. User equals request dot get session. Get attribute user, and you have to specify it's a user. A lot of times we just store things like strings, right? We don't need to actually store the full object. In my case, I'm going to just because I can, but I don't always do that. In fact, I frequently just use the username. That's more than enough. Since I'm the only person that can set that attribute, that's fine. And I'm going to return u dot get username. Okay. In fact, I might not even do this. We might fix this later. But anyway, so how do I know if a user's logged in? That's the first thing we're going to check, right? Well, if the session's null, that means this is the first request, right? We're going to find out that's not really true, but we'll talk about that in a minute. Then we're going to get the attribute, okay? And with the session to get attribute, if it's been set on this session already, that means we've logged in, right? Only the server can set attributes on their session, so that works out really well, right? we set it to null. And then because we can store items in it, we're going to actually go ahead and get the attribute, find out which user's logged in, and get username. That session is going to be a different object for every single user that's logged in. That is what's coordinating requests between for a single user. Now, that seems hardy enough. Let's go ahead and log out. And you go, wait a second. I want to log in first. And it should be students. Let's do this. Students. Okay. I want to log in first. Yeah, not what I want to do. Right? Okay. Because I do this differently every time I teach the course, by the way. Some people don't believe me, but I do this differently every time I teach this course. I'm going to return a string. You really can't return void, so don't try to return void. It's really bad. But what I'm going to actually do is instead of session, instead of using servlet request, I'm going to get session, and I'm going to say session dot invalidate, and that's going to wipe out the session and return done. Again, do not try to run this. Do not try to work this without having. I'm not joking. Make sure you return something. The server is going to act like a fool if you don't return something, even if it's a command that you don't really need the return for. Now, you note in the delete, excuse me, I opened this up. In the delete option, right? If you look down at the delete, we did this already. Delete doesn't need to return anything. In fact, we returned the SID. I don't know why we returned the SID, but we did. But if it doesn't return anything, we can't actually send the statuses back because it just won't return anything. It's number one, so Angular will never know if it was sent or not. That's a problem. The second thing is even on things like logout, where you don't need any response, if you don't send done, it won't indicate that it's finished, which is a huge problem. Okay, so I already have this up and running. And so I'm going to go to login test. We don't have a login, as you might have guessed. Oops. It's students. We don't have a login test, but we have user. We have no user. So that's the point I was going to make. On the first request, the session is created. This will never return null. Even right after being invalidated, it will never return null. And as a result, we don't really have to do that. We can just use the session object, and we can just inject the session object instead of the servlet request object. Pretty easy. All right. What else can we do? Oh, yeah. So we did the logout. Now, we can't actually log in, so the logout's pretty useless. But here's the kind of the interesting thing is we don't have any logout method, right? Right? But it'll still say done. Why? The session exists and we can invalidate it over and over and over as often as we want. All right, so let's go ahead and get the login. We're going to go ahead and grab, I know this is a little crazy, and we're going to get, it's going to get annoyed with us, but that's fine. Okay. All right. So we don't want that. We want to return the user. And we want, ooh, it's a put mapping. So I did this wrong. Log in. Post is just better. We don't want valid because I don't want to worry about valid. I know we need a username. Otherwise, it'll blow up. So that's fine. We need at least a username. We can do things like that. But we never want to worry about or accept or deal with admin. So there's some things we probably want to avoid from a validation point of view. So we don't always validate, but you'll see what happens in a minute. So we're going to go ahead and take a user. And let's say sent. This is the user that was sent. And I'm going to return sent. Nope. Okay. And I'm doing this just so that we can, I'm doing this just so we can, oops, I'm sorry, I have to return. No, there you go. I'm doing this just so it won't complain at me. Okay. So the first thing we need to do is find out if that, did I not name it users DB? I just named it users, of course. I can never remember anything. Okay. So exist by ID, right? And so we're going to go ahead and send dot get username. Yes. If it exists, it exists. Now, here's a complicating thing we're going to deal with. Okay. I apologize. This is going to sound awful, but we're going to deal with this. So we're going to have a bunch of possible errors, but from a security point of view, we are going to deal with them all the same way. And I'll explain why when we're done, when we're doing it. So if the user exists by username, I want to go ahead and get the real user. And I want to go get users dot find by username and sent dot get user. Now I could definitely do this and just check to see if that result is null. But I'm just used to doing this. So note that I have a real user and the user sent. I don't actually want to make sure I mix them up. Now we're going to check the password. We check the username. Now we're going to check the password. If real dot get password, it's a string, right? So equals sent dot get password. We should log the user in. Big. And so we're going to do that. And how do we do that? We take the, we need the, oh, excuse me. We need the HTTP session. And we're going to go session dot set attribute user, and we want to set the real one. Now, you don't know this yet, but I'm going to do it now. We're going to go ahead and set the attribute admin to real dot admin, right? No. I'll explain why. We don't see, we can check to see if it's there by seeing, excuse me, we can check to see if it's there by checking the attribute. So we don't need it to be there and then check the attribute. We can just simply, if real is admin, then we're going to go ahead and set an attribute, and it could be anything, right? It doesn't really matter. We set it to be real.admin, but true works just as well, as long as it's set. That's the only important thing. Okay. All right. Now let's talk about the failure. If real password does not equal, what happens? I'm doing this. I'm sorry. Passwords don't match. We would actually give attackers information about how to attack our system. They would know that the username is correct, but the password is not correct. So we don't want to give them that information. So we don't want to send just password's not correct. Oh, come on. What did I even do? I clicked build, apparently. I'm not sure how I did that. I just want to click backspace. I didn't want to do that either. There we go. I don't know what it thinks it's doing. I'm a little annoyed. All right, anyway. Passwords doesn't match. User doesn't exist. Right? We don't want to send that information. All we want to do is return an error. And so what kind of error do we want to return? So first of all, the status, oh, excuse me. I actually don't want to, I just want to copy it. The status okay is fine. Okay. That's what we're going to send here. We're going to send the sent. We're not going to actually ever send the real, but we're going to send the sent. Here, though, if we get here, that means the password didn't match, the user didn't match, something went wrong. So what are we going to do? We're going to send, I think it's not authorized. Nope. Yeah, unauthorized. I'm going to send a 403. Bang. And that's going to indicate that the user's not logged in. All right, you ready, Freddie? Let's get this party started. So now We have log out, excuse me. Here's my post. I have a body here, username, password, Mike. Yeah, I sent admin is to be true, but it doesn't really matter. I'm going to send that to login and said method not allowed because it was student slash login. Did I do that wrong? Yep, that post mapping should be this. Also, that didn't exist in the previous run, so kind of funny. All right, it wouldn't have worked anyway. So let's fix it, and then we can log in. Then we can do authorization stuff. By the time we're finished with today's class, we'll actually be able to have all the authorization done. But first, we got to do the login stuff, which will actually be done very shortly. Okay. So now I'm going to send the login. And I get an internal server error. So we get a compilation issue, which is great. Let's see what the compilation issue is. Failed to convert from type to byte. Hold on. Yes, that's a problem. Okay. So this is why we have to implement serializable. It's because it has to be convertible. We never did that because we just didn't do it before because we let it automatically do it, but that will not work. So let's try this again. Sorry if you can hear my dog barking. I'll be done in just a minute. I'm not sure why she's barking. It's very late at night. It's 7:15. Okay, so now I'm going to send the login and we get an okay. Okay, so now when I do my login test, right? Nope, I just sent log out. Shoot. Unfortunately, I logged out again. So now I gotta log back in. Yeah, here we go. This is a login test. You can see I'm logged in as Mike, right? So functionally, I'm logged in. If I go to, I want to point out something real quickly. If I go to log in again, what happens? I remain logged in. It doesn't do anything. But I want to show you a couple things that is problematic. Okay. I didn't notice this the first time I taught this class, but I noticed it later. So if I log in and I'm already logged in, right? I'm already logged in, no issue. Already logged in, but I'm going to try to log in as Ruth, right? And I'm going to log in incorrectly as Ruth, right? Somebody noticed this. Somebody noticed this in a previous semester. So I get it unauthorized. But watch this. I'm still logged in, and I'm logged in as Mike. We should actually fix that. And what we could do is simply put what we're doing here is allowing the user to switch privileges or go up a privilege when we should have them log out instead. So what we're going to do instead of that is just simply log them out, right? And so one way to do that is when they go to the login page, we can actually just essentially log them out, right? By doing this. The second, before we actually do anything, right? They're trying to log in, clear out any old logins, right? And then we go to, I'm sorry, I'm brain farting. Here we go. Invalidate that one line of code here. Right? That one line of code will prevent that situation. I'm not going to go to test it to show you. A couple of things I'm going to talk about briefly before we go on to authorization and before we go into our first endpoint. A couple of things I want to talk about really briefly. Session is not the only object which you can store information in. We have avoided it like the plague because we have a database that everything we need for the database should be in there. But there are other things we can do. However, Once we do that, the load balancing problems are unavoidable. So we don't want to do that if we can avoid it. And so we should avoid it. So we're not going to look at those other types of objects. They're not actually useful for our purposes. So we're going to go ahead and leave them. Okay. Fortunately, a lot of what we do doesn't depend on it. I'm actually going to stop the recording and come back just because I'm going to try to break it up a little bit rather than have very long ones. All right. Thanks.